bit of a interruption there. So continuing on, actually notice that my power here, I forgot to take 1 off, so it's actually the power of 8. And this is essentially my answer. I could, and what they do in the example is they move it, so they just bring the 9 out the front. 6x plus 2, because everything's multiplied through, we can just manipulate the terms around. Plus 2x, take 1 to the power of 8. Perfect. So let's get rid of this. Let's do part C. So looking at part C now. Okay, so this is currently as a surd or as a square root. So what I want to do is use my knowledge of indices to recognize that this is essentially 3 minus x to the power of a half. So finding the square root is the same as raising to the power of a half. And now that I have this, I treat it just like normal. So if I need to find the derivative of my brackets first. So 3 take x, if that was a. The derivative of a is just -1. Remember the constant cancels out. So therefore, y dash, which is the derivative of my original function, equals the derivative of my function inside, which we found was -1. Bring my power down times a half. Keep everything that's in the brackets, 3 minus x, and take 1 from the power. So a half minus 1 gives me minus a half, doesn't it? Yep. Okay, so from here, let's simplify what's out the front. So -1 times a half gives me negative a half. 3 take x to the power of negative a half. And when we have it's often not, or we often don't keep it with a negative in the power, so we can convert this to be, or this is the same as, I guess, negative 3 take x. Sorry, -1 over, isn't it? Because we have a negative power. So -1 on 2's on my denominator, and the negative brings my function down to the denominator. 3 take x, and last bit is the over 2 means the square root of. Okay, so I've written this a little bit wrong. Get rid of that, and to swap it from a half, I just put root x, and that should be my answer there. Perfect. So this is probably an easier formula to understand. So you might see a pattern when using the chain rule. The derivative of a composite function is a product of the derivatives of 2 functions. So the way to look at this rule looks quite a bit complicated, but essentially if we have a function raised to a power, what we do is we find the derivative function, which is what we were doing before. So we find the derivative of what's inside our brackets, and then we just treat it like normal. So we bring our n out the front, leave our function in the middle, and take 1 from the power. So that's just, I guess, another way of writing it, not the dy dx version, which can often be quite complicated to understand. So on your formula sheet, you are given this at the top. So make sure you're familiar where that's located. So if you're asked to find the derivative of a function on your test, you'll be able to know where that is. So here, differentiate these. So this is quite similar to what we literally were just doing before. That's a bit strange, that's moving. Okay, so let's have a look at part A. So essentially I'm finding, let's set u this time. I think they like to use u in the textbook. So the derivative of my inside function. So 3 times 8 gives me 24x squared, and my constant cancels out. So same thing now. So to find my derivative of my original function, I get the derivative of my inside function, which is 24x squared, and then I just treat it like normal. So I bring the 5 down, multiply it by 5, bracket, leave whatever was in my brackets the same, and decrease 1 from the power, so the power of 4. So now I just simplify the terms out the front. So 24 times 5 gives me 120, x squared, 8x cubed minus 1 to the power of 4. Cool. So part B. We'll do part B over here. That was part A. Same thing. Set u equal to your inside function, or 3x plus 8. By the way, this here was u dash. I skipped a step there. So therefore, u dash equals 3. So now I'm going to derive it just like I would. So bring my inside derivative out the front. So y dash, so deriving this function equals 3, and then bring the power down. Leave the brackets the same, and decrease 1 from the power. And then just simplify out the front. So that's 33, 3x plus 8 to the power of 10. Perfect. Let's look at C now. So let's get rid of some of this working over here. Okay, part C. The fact that we're given 1 over something indicates that we need to swap it to have a negative power. So remember, 1 over just means a negative power. So let's rewrite y so with a negative power. So it's, oops, y is 6x plus 1 squared and negative. So negative 2. Same thing. Find the derivative of my function inside first. So 6x plus 1 means the derivative of my inside function is just 6. Treat it like normal. So the derivative of my whole function equals the derivative of the inside function, which is 6. And bring the power down times negative 2. Leave the brackets the same. And subtract 1 from the power. So this gives me what? Negative 12. 6x plus 1 to the power of negative 3. And considering negative 12 is negative 12 over 1, I can invert because of my negative here. Remember, I don't like to leave negatives as a power. So I'm going to leave my numerator on top. So equals negative 12. Bring this down. So the negative is just going to bring this to the denominator now and leave it to the same power. So 6x plus 1 cubed. And that's it. So good luck with the chain rule. Remember that you can locate it on your cheat sheet for upcoming tests, etc.